A resistor with R equals 2.1 kiloohms is connected to an AC generator that operates at 60 hertz with an amplitude of 42 volts. Alright, so I want to find the max current in this AC circuit. I know the voltage drop across the resistor, and I know the resistance. Alright, 42 divided by 2.1, 0.02. Amps. Alright, so that's our max current. We want the maximum instantaneous power. So let's do P max will be V max times I max. Alright, that'll be 42 volts times 0.02 amps. I get 0.84. So that's going to go here. Find the minimum instantaneous power dissipated in the resistor. So if we draw a graph of the voltage and the current, we can see what the power will do. So let me go to browser. We can construct a function for the voltage. You could call it V of t and put in the amplitude of the voltage. We were given a frequency for this oscillator. The frequency was 60 hertz, as I recall. Yep. So we can put that in as well. The formula for the sine wave was going to be 2 times pi times f times t, where f is the frequency. So we want then to put in that 60 here. This creates a function for the voltage. I'm going to have to rescale the axes. We got to zoom way in. Okay, now we can see the voltage. We can also make a function for the current. Current has a maximum amplitude of 0.02. 0.02 sine of 2 pi times 60. Perfect. Now we want to make a function for the power. To get a function for the power, you just multiply the voltage function times the current function. And this green is a picture of the power. So power in this situation will not go negative. It just goes from 0 up to a maximum value. We already said that the maximum value would be 0.84. But they're asking what the minimum value is, right? So the minimum value is the lowest value that it goes to. That's 0. So that's going to be the answer to this one. Minimum instantaneous power is just 0. Next, it wants us to find the average power dissipated in the resistor. So for that, we can use a couple of different formulas. One of them is to just do V max I max divided by 2 for this situation. Why would we do that? Because as you saw, the power graph, it just starts off low and it goes high. And it goes back down here, and then it goes high again. There's a symmetry to it. And so you got the peak at the top. That's going to be P max. And then here at 0, you got the minimum. Somewhere in the middle is the average. And because it's symmetrical, this shape, the average ends up being right down the center, halfway between 0 and the max. And so that's why I'm saying that the formula could be V max I max over 2. Alright, so that's what I would do here. We'll do the max power, which is 0.84 watts. And we'll cut it in half. That's the average power, it's called. It's 0.42 watts. Another way of finding the power, the average power, would be to find it through this formula. You can do V RMS times I RMS. Alright, so right now we don't know what the RMS voltage is, but what would it be? It would be 42 volts over radical 2. And then the IRMS would be 0.02 amps over radical 2. So you can see where this 2 comes from in that formula. Like those formulas match up to give the same value. So it's going to be 0.42 watts. Alright, next, how long would it take this resistor to dissipate 500 joules? We want to dissipate 500 joules, so I would just use the power formula, the other power formula. Power equals the energy dissipated divided by time. And so that's going to be an average power that they're talking about there. It's certainly not giving off 84 watts all the time. That's the peak. So we want this. And the number of joules that it wants to dissipate is 500, so I put that up here. Then we should be able to solve for T. I get 1190 seconds.